Hi, everybody. I'm Sunny, and this is We Gotta Talk, a live weekly digital talk show and podcast where we like to dig deep. Real talk, big topics. Now, let's dig in. Hey, everybody. Welcome to this episode of We Gotta Talk. I'm really excited. Frankly, I'm a little emotional about today's guest. He is a wealth of information about extending your healthy life. His name is Dr. Dayan Goodenowe. He's a PhD neuroscientist, and he's an expert in the biochemical mechanisms of disease, which is essentially a long way to say he's teaching us how to live longer and healthier, and firmly believes that disease is not random. It's not unpredictable. And in fact, with the right knowledge, supplements, and lifestyle changes, you can drastically change.
Hey, Sunny, we had a glitch here. Producer Rachel.
Do you have me now?
I do. You froze for a hot second right during your intro.
I'm like surprised. I know. My darn Wi-Fi. Okay, where did I cut off? Because I want to make sure we give this guy the introduction that he deserves.
I think just start over with that introduction. Try maybe refreshing, Sunny.
Pop on Dr. Dayan Goodenowe and producer Rachel. Can you hear me now?
Yep.
Hi, Dr. Goodenowe.
I think we're all here. Can you hear me?
Literally, we chatted for 15 minutes before the show started, and the universe picked that moment to make my Wi-Fi not work. Anyhow, as I was saying, Dr. Goodenowe is a PhD neuroscientist. He's an expert in biochemical mechanisms of disease. And Dr. Goodenowe, what I love about the bio that we have for you here is that you say you believe disease is not random, it's not unpredictable, and that we, in fact, have so much more control over the health of our brain and bodies than we've previously been led to believe.
Thank you. Yeah, that's exactly correct. And we think we give disease way too much power. We give it deterministic qualities, which it does not have. Disease is opportunistic. Disease is what divides us. Health is singular. Health is a singularity. Health is the same for everything. It's the disease that separates us. And so you get common stressors to our environment, and then these common stressors will create a multitude of reactions. It's just like a person jumping into a crowded room with a gun. You're going to get 20 different reactions. Some people are going to hide under the table. Some are going to run for the exit. Some's going to attack the aggressor. Same thing happens with health. And so we get a singular stress will create a multitude of reactions dependent upon our individuals. So our genetic diversity doesn't give us disease, it chooses them, but it only has the choice based upon the stressor. So disease is opportunistic. It can only occur in the absence of health. Disease is not a little Pac-Man waiting and chewing at your body. It comes when your body loses its health. And so we can identify that well in advance and then correct it.
So the work you do really focuses on neurodegenerative issues. Your book is called Breaking Alzheimer's, a 15-year crusade to expose the cause and deliver the cure. But your work also really touches on Parkinson's, autism, cancer, anything that can originate or impact the brain health. What do these diseases have in common?
Yeah, so what happened for me, like my background is in synthetic organic chemistry, so I actually make stuff. And then my PhD is in psychiatric medicine, looking at the biochemical mechanisms of psychiatric diseases. And then back in the 90s, when we had the genomics revolution, we were sequencing all the genomes. I was involved in a lot of functional genomic research at the scientific level. But we didn't have a biochemical equivalent of gene sequencing and comprehensive biochemistry. And so as a chemist and as a biochemist, I invented a technology called non-targeted metabolomics. I know it's a long word, but it's basically the ability to take a blood sample and measure thousands and thousands of molecules in the blood. I've measured 500,000 molecules in biological systems. And so it gives us an indication of how the body is operating. It's almost like a biochemical version of forensic accounting, where you can see, okay, where's the money going? And so here we say biochemically, is where's the biochemistry going? And it's supposed to work. And so when I started applying this first, back then when I was just a young, up and comer, we were looking at diagnosing disease. So, hey, this is great. Like if I can see person A with a disease and person B without a disease, there's got to be a biochemical correlate of that. Because if I can physically see the difference, there's got to be a biochemical difference. And that turns out to be true, right? So we find the biochemistry of someone with ovarian cancer, the biochemistry of someone with breast cancer is different than someone who does not have that disease. And traditional thinking has always been that the disease is causing these biochemical changes. So, wow, we got this diagnostic test. I can say, hey, you have breast cancer. Hey, you have ovarian cancer. You have Alzheimer's disease. And so then we started doing research studies where we looked at before and after surgical removal. And the big eye-opener was we did 2 separate studies in Japan on colon cancer. So we have blood tests diagnosing for early risk factors for colon cancer. It's available in Japan, and we do it here. The biomarkers are very powerful. So we thought, wow, this is great. We're going to do a study in Osaka, Japan. We look at people before and after surgical removal of the colon tumors, expecting that the biomarkers would return to normal after we got rid of the tumor. So we did the big study, no change. Biomarkers were exactly the same after tumor removal as they were before tumor removal. So what's going on here? So clearly the biomarkers the tumor wasn't actually chewing up these biomarkers. The biomarkers pre-existed or predated the cancer. We didn't even believe it. So I did an entire new study in a different city, a different academic group in Chiba University, the other side of Japan, got exactly the same results. And this is where it really started beginning to say, look, what we're actually biochemically measuring is we're not measuring disease, we're measuring people who get disease. Okay. And so now you're saying, okay, why? So, why does this woman get ovarian cancer and her sister doesn't? What's different? What happened? And so there's a biochemical optimization that we all have, and we can lose that optimization. And a good example is, say, diabetes and complications. So no one really dies of diabetes, right? You die of cardiovascular disease, you go blind, you get diabetic neuropathy, you get complications arising from diabetes. So if you're diabetic and you have diabetic neuropathy, okay, you don't just say, okay, I'm going to fix the neuropathy and I'm going to keep your blood glucose level at 200. Okay, no, you have to deal with, so I can fix the neuropathy, but I still have the pre-existing causation, which was the glucose, poor glucose utilization. So this occurs in all diseases. And so prodrome sciences deals with this concept of identifying disease prodromes. And then, so you have health, and then the health gets deviated, and that deviation gives you risk. So low plasmalogens for Alzheimer's and cancers that we just published a bunch of work on breast cancer. So there's different biochemical changes that occur. So you have different phases. You have a health stage where you're healthy and you are at a low susceptibility for disease. And then at some point in time, that health state gets into a high risk state. So now you have a risk for disease, but you don't actually have the disease. Okay, so at some point you have full tread of tires. At some point you have a bald tire. But when you have a bald tire, it doesn't mean you're flat. It doesn't mean you can't drive around. And you could run on a bald tire for years and years and years and never even know it. It's only if you get if your environment creates the right trigger that you now with a bald tire get a disease. So you have a healthy low risk state, you have a high risk state pre-disease. Then when you have a disease, you end up with 2 things. You end up with the disease itself plus the pre-existing biochemical abnormality that puts you at that risk in the first place. And so current medicine focuses on taking a bald tire and putting a patch on it and putting a bald tire back on the road again. And when you do that, what happens is you just move everybody. So what we're doing is, like in human longevity, for example, what we're doing is we're not increasing human lifespan. We're increasing the number of people who die late. So we still don't live longer. We just don't die younger. And it's a very different concept. So we have less and less people dying of chronic diseases earlier, but we're not actually improving human lifespan or human vitality because we're not
Right.
You don't really teach it.
What I'm hearing you say, and this is from a layperson's perspective, and this is what really shifted my understanding of what you do. It's like a savings account,
Yeah,
or it's like
exactly.
a deck of cards, right? You lose a few over time, and if that deck gets thin enough, or if that account gets low enough, that's when you begin to see disease pop up, because your defenses, your savings,
Yeah.
the good stuff isn't as high as it should be to protect against it.
Yeah.
So what you're saying is, with all of the work you do, you can actually teach people to build back up. What is the foundation of rebuilding that health and making those accounts big again, those decks big, those accounts full of good stuff,
Yeah.
so that we can avoid disease?
Well, so the first thing is understand there's really some basics of physiology. See, scientists get bored easily, so they don't like to talk about the normal stuff. So we're always trying, if you want to publish a new paper, you got to add something to the previous history. So we got 50, 100 years of really excellent research, but we've forgotten most of it. So the first thing you have to realize is how the human body actually works. Fundamentally, the human body is a hybrid electric car. That's how we run. We burn hydrocarbons, we food. Like we basically return sunlight energy back to the universe. That's what humans do. Okay, sunlight comes in, converts carbon dioxide and water into glucose, which is a complex carbon. That complex carbon becomes part of what we do. So we eat food and we burn it into carbon dioxide and water. And we use the energy from that, just like your car engine does, but we use it to charge a battery, like physically a battery, just like your car is like a lead battery or whatever. All your cells of your body have mitochondria, and that's your battery pack. And it's a proton gradient. And that battery charge runs ATP pump. And all the oxidative stress, all inflammation of the human body, no matter where you get it, ultimately comes from mitochondrial dysfunction or mitochondrial insufficiency. So first and foremost, you need to keep your battery charger working. And we breathe in oxygen, and we take that oxygen and we use that oxygen to neutralize into water, and we pee out the water, and we breathe out carbon dioxide. And that's what the human body does. So that's number one. That's the energy utilization, maintaining good mitochondrial health. And that's part of, people talk about fasting, they talk about keto diets, they talk these things as we normalize, but that's number one. And the second big issue is your membrane structure. Like your body, you're not a bowl of soup, right? We're not a vat. We're not some, brewery where you're brewing beer. Your heart cell is separate from your lung cell, separate from your brain cell, and even inside your cells, they're separated. So just like your house, you separate your kitchen from your bathroom, from your bedroom, so you can do compartmentalized work in different areas. How the body compartmentalizes itself is its membrane structure, its phospholipids, and we want to make sure those are properly done so that your body functions, and we can measure those and make sure and those are the things that start deviating from normality. And the other thing, like, you're not an automobile. Like when your metal wears out, it doesn't wear out, right? Your heart's beating 60, 80 times a second, a minute for 50, 100 years. Like, what thing has humans ever created that can last that long? Nothing. Like, we can't build anything. So
let me hop in here with a quick
Go ahead.
question too, because you're bringing up all these really sort of bring it down to earth, these points about how we can extend our healthy lives. Humans, like you said, really aren't designed. We weren't meant to live an exceptionally long period of time. In fact, the current time in history, we're living longer than we ever have, but also with more disease and more complications. Is the goal of your work to extend those healthy years? Do you ever foresee a future where, if the work you're doing is implemented properly, disease could be eradicated? Because it feels too good to be true, but yet when I hear you describe this, it actually feels possible as well.
It's logical. There's no time stamp on human longevity. Okay, human death is basically apathy. Okay, it's an apathetic death, and so the real war is against entropy. Okay, so the second law of thermodynamics, where things try to reach disorder, and how we maintain order. Just like in the morning, right? You get up, your bed does not want to stay made, right? Your bed gets messy. You put clothes on it, so you're constantly applying external energy to your bed to restore the order in the bed. So the bed always becomes disordered, and so we biochemically maintain order, and we do that by applying external energy into our systems. But there's no logical, when a person's 110 years old and dies, not every single cell and system of their body dies. If they die of pneumonia, their heart's still working, their muscles are still working. So clearly parts of their body were still functional at 110. They didn't expire. So there's no such thing as an expiration clock on humans. What happens is you have this people think of aging as a disease. Aging isn't a disease. Aging is just an association. You have a higher probability of something going wrong the longer you wait. Okay, that's all it is. And so, anyway, so my bottom line.
Yes.
So for me, longevity, increasing function, and the bottom line, people think about immortality, longevity, and all that stuff. That's all basic, I want to say a bad word, but bullshit, because you can't live your 100th year today. Okay.
Right.
You can only live today's day today. And so the goal of immortality is living an infinite number of good, healthy todays. So if I'm healthy today, I want to be healthy today forever. I don't want to live my 120th year. I want to live my next day as healthy as I am today. And if I can do that successfully, that's the definition of immortality. But somehow waiting and thinking that, that my 120th year is going to be some miraculous thing. Well, that's mortality thinking, that you're thinking death already.
Right.
You're already predicting your death. So you're
then how do we die? Say we master the art of self-preservation, biochemically, neurologically, physically, muscular, our musculature. Mm-hmm. What do we actually die of then? Well, this is getting quite existential.
You get hit by a bus, basically.
Okay. I was going to say it almost makes it seem like too good to be true, but we all meet our end at some point. But you're saying the science that you're working on today essentially just gives us back the quality of the years that we have left.
Yeah, but says who? So it says who? So
would you want to live forever though? I mean, philosophically speaking, I want to live long and I want to die in my sleep, which is, I feel like, what everybody says. But I also really struggle with what purpose would I feel that I had a certain age, or what level of spiritual exhaustion would I feel? This is kind of taking it in a different direction, but I'm just curious to know, would you want to live forever if you could?
It's not really, if I could, again, I want to have function indefinitely. Okay. To me, it's indefinite function. So the numbers, like the year of your birth is an irrelevant number. And so I want to get to the point where I don't even think of age. I don't want to think of how old I am. I don't want to care what years I have behind me. I'm interested, for me, immortality focuses on three things: your mood, your mobility, and your mental acuity. If I can keep those three things, if I can think critically and enjoy doing things, if I can move in my world, and like you said, emotionally, if I feel good, that's all I care about. And if I can maintain those three functionalities. So immortality is just the maintenance of functionality indefinitely. That's all it is. It's not complicated. We put these weird things on. We talk about clocks. We talk about telomeres and methylated genes and this and that. But see, people have it all wrong. Your genes are not deterministic. Your genes are reactive. Your genes are there to save you from all the dumb shit you do every day. Okay, it's basically because they're hiding behind a curtain, right? They're in the nucleus of your cells, and they can't see the world around itself, right? And they have these proteins and things, and you go out and you have pineapples, or you go out and you stub your toe, and you get some sort of sensor, and the gene says, okay, what's going on? How do I react to this? And it wants to protect you from that. And what happens when we get older, just like we psychologically get older, we become less risk-taking. We've learned, our learned biases overprotect us to death. Our genes basically protect us to death. Is what happens as we get older, because they've learned all these protective mechanisms. It's like you when you're young. Like, say, you don't do the dumb stuff you did when you're younger, because I've done that. I'm not doing that again. And so you lose that level of plasticity as you get older. And so you need to create safe places so the body feels confident enough to maintain an open, risky operating system. I know it's all philosophical. Sorry,
I love that. Yeah, no, that was a very apt description. It's interesting though, because the work you do could potentially enable people to live much longer. And I think these sort of intersecting questions probably come up in your mind even as you're doing this research. What are you really equipping people to do if we're giving them X number of years more, X number of healthy years more of their lives? It's actually quite beautiful too to think that if you can give someone the gift of health and mental acuity and happiness, that could lead to so much more good in the world. It's
like
you
a
know,
zero
the
sum
idea
game.
of
Like if you work for a living, it's like saying, well, sooner or later you're going to go broke. Sooner or later you're going to go. Well, no, I'm never going.
you don't have to, right?
There's no reason you ever go broke.
So talk to us about plasmalogens, which is, I feel like, the cornerstone of all of the research and work you've done, and essentially feels to me from an outsider's view like the key to all of this good stuff happening.
It's a really critical one. What's nice about plasmalogens, it's a nice Trojan horse. It says, you know what, let me talk about plasmalogen. Well, I got your attention. Let's fix a few other things while we're at it. But plasmalogens are one of those molecules where, like, look, I'm an expert in neurological disease, biochemistry of synapses and neurons. Okay. So I was doing a study in Alzheimer's disease, another study in Japan and one in North America. And we saw these low levels of blood plasmalogens in the blood using this non-targeted metabolomics technology. And I'm going, what are these things? And they correlated with the severity of dementia. And I'd never seen these molecules before. I said, what are these things? And so I literally had to Google these molecules and found out they're plasmalogens. I go, well, why haven't I ever heard about these things? And so then you dig deeper and deeper, and we've known about them for about 100 years. We know they're obligate to human life. Like children that are born with mutations in plasmalogen biosynthesis have dramatic neurological dwarfism, like the disease is called rhizomelic chondrodysplasia punctata. There's like Zellweger's, Refsum's, there's a bunch of diseases that affect that. But if you're born with the inability to make plasmalogens, your body, you can't develop. They're bedridden. Even babies that are born prematurely, some of them will get a disease called bronchial dysplasia. That's also caused by plasmalogen defects. A lot of the problems that women have when they're pregnant, because they're manufacturing a lot of plasmalogens for the babies, a lot of the brain fog and a lot of the reduced cognition is caused by these reduced plasmalogens.
Wow. And
we're not dealing with the thing is, they're not a small amount of molecules. Like you're talking 20 to 30% of your neurological membranes are these plasmalogens, and we get none of them from our diet. We manufacture them all ourselves. And so this is crazy. It's one of those crazy things. At first you say, wow. And then you go, you feel a little angry that how is it possible that something, it's like not recognizing there's a moon circulating the earth. Like this is a big part of our physiology, our lung function, heart function, kidneys, the retina of your eye, huge levels of plasmalogens. Even the epidermal layer of your skin has ether lipids that are responsible for that epidermal layers. So these are low. And so we've known about them early in life. So I discovered these molecules being decreased. I developed and I researched all their epidemiology and basically discovered this plasmalogen mediated diseases of aging. So they typically peak in our 40s to 50s, and then they start declining afterwards. So this decline, this age-associated plasmalogen decline, basically once you start making less than your body needs, it basically starts dripping out of your brain. Like you just start losing it. Like it's just like your reserve capacity, like your brain shrinks, right? So the shrinkage of your brain, the shrinkage of your membranes have a lot to do with just inability to maintain plasmalogen levels.
And if you can plug back in and either encourage your body to produce its own or supplements, which I know is something that you've also been working on with Prodrome, are you immediately seeing a reversal in the symptoms of some of these diseases? And if so, how does that look? How quickly does it happen? What diseases does this supplementation help with? Because this sounds like magic juice.
It is magic juice, and it's crazy. So we did present this work at the Alzheimer's the Alzheimer's Association International Conference held in July. Presented 2 sets of data sets from clinical trial we did in Santa Monica using plasmalogen precursors in people that have cognitive impairment. We saw a statistical improvement, not just a delay in cognitive decline, actually cognitive improvement statistically in a small group of people in only 3 months. More importantly, like we had people with a clinical dementia rating of 2 to 3 going down to MCI level. Like I have people that their lives have been restored because the plasmalogens have been restored. And mobility, like when we measure sarcopenia, so people forget about Alzheimer's. They think, oh, it's just cognitive decline. But most people with Alzheimer's, if you go to an Alzheimer's ward, you'll notice a lot of them are in wheelchairs. So there's a huge mobility issue with Alzheimer's disease. So we saw significant improvement in muscle strength. So a simple test that we performed on all the participants was a sit-stand test. Basically, it's a timer. for 30 seconds. You ask someone, stand up and sit down as many times as you can in 30 seconds. And people can do anywhere from 10 to 30, depending upon how fit you are. But after only 3 months, we had people with 3 to 5 increased sit-stand rates, highly statistically significant improvement in sarcopenia measures, because the neuromuscular junction is like a neuron. And the cholinergic system, like people, of your listeners who have parents and things with Alzheimer's, they quite often there's a drug called Aricept. And that's a drug that elongates the acetylcholine function of the brain. And so acetylcholine is also what your muscles use for your neuromuscular junction. So anyway, so we're seeing clearly significant improvements. The people that are using it around the world, our functional medicine doctors, are seeing some pretty significant reversals in Parkinson's, multiple sclerosis, optic neuritis disappearing, diabetic neuropathies disappearing. So
I want to talk about Parkinson's. I've been open about this on the podcast before. My mother was diagnosed about 5 years, and it is, as with any neurological disease, so uniquely heartbreaking because of the sort of varied outcomes that you have, and the lack of knowledge about where we're going to be with her in 1 year, 2 year, 5 year, 10 years. And, I know probably people that you've worked with who have Alzheimer's or their families have that similar sort of extended period of grief and worry. So I'm hearing you as a family member of a person with a neurodegenerative disease, and I'm hearing so much hope. And I want to know and speak to this audience of people right now, because they're hearing what you say, and I'm sure they're like, oh my God, I need to get my hands on this, or it sounds too good to be true. Focusing on Parkinson's specifically, what have you seen with Plasmalogin supplementation in those patients? And this is like the question that we ask her doctor all the time. Can we really turn this around in a meaningful way?
The answer is yes. So Parkinson's disease is a dopaminergic disease of substantia nigra. It's a little pea-sized set of neurons, and people think of the brain as a connection, all connected, but it's not. It's the outer part of your skull is like a beach ball, and the outer part gives you the maximum surface area. That's where all your synapse happens. Okay, and then inside you'll have cell bodies, and then you'll have these fiber tracts, which is the electrical wiring, like in your wall. And then you have these signals going back and forth through these white matter fiber tracts. So we have a little body of neurons called, in the substantia nigra, dopaminergic neurons. The main part of brain activity is glutaminergic. I'm getting in the weeds here. So for Parkinson's, most people, low levels of plasmalogins pre-exist in Parkinson's. We've done it in several studies showing that when we do blood testing, blood plasmalogins are low in people with plasmalogins, low with Parkinson's disease. So when we treat Parkinson's, there's a couple of things about it. So one, we want to improve the neurological function of the existing neurons. So what happens in Parkinson's is that you have quite a large reserve capacity for it's fine motor skills. And we've shown that we can prevent Parkinson's disease. So there's a animal model called MPTP. Interesting stories. Kids in California were trying to make designer heroin back in the 80s, and they gave themselves Parkinson's. And ever since, and so they were trying to make this designer heroin. And when someone when they looked at what someone did, researched what the byproduct, so they made bad batches of this heroin and gave themselves Parkinson's. And the molecule that they were making was a molecule called MPTP. And this is a molecule that selectively degenerates dopaminergic neurons. And so we've used that now extensively for the last 20, 30, 40 years almost now, to study Parkinson's. But if you give animals plasmalogins in advance, and then you give them MPTP, it completely prevents neurological loss. So plasmalogins completely prevent neurodegeneration. Also prevents demyelination. So we've done that. And so then we have further studies where we looked at treatment of plasmalogins after breaking the dopaminergic neuron down, and we get recovery. Okay. And so so in Parkinson's, there's practical realities, right? So early on, people are really worried about L-DOPA because L-DOPA works really good and really well, sorry. And then they eventually it tapers off. So one of the practical realities of Parkinson's therapy is to maintain L-DOPA efficacy for as long as possible, because L-DOPA itself, as miraculous as it is quite toxic. It causes methyltransferase issues of the brain. So you want to kind of protect yourself from the cure, essentially. and plasmalogens can help do that. So we show that it reduces L-DOPA-induced dyskinesia. So what happens with people is that they take the L-DOPA for a while, and then they get their motor control back, but eventually they get uncontrolled movements called dyskinesias. And the plasmalogen therapy has been shown to reduce dyskinesias. And so if we can, so we want to preserve the neurons that you have remaining. We want to make sure the neurons that you have remaining can function at a higher capacity and maintain that higher capacity indefinitely. And then ultimately you want to be able to commandeer other neurological systems to help carry some of the water for those dopaminergic neurons. And so that's kind of a fundamental strategy. And yes, we've seen some dramatic reversals.
I was going to say, what does that look like practically? So if someone is years into a diagnosis, and as we said, diagnoses and symptoms vary wildly along the spectrum, but just say someone has mild Parkinson's, but is years into traditional treatments, the therapies that you mentioned, what does supplementing with plasmalogens usually look like? Is it a decrease in the involuntary movements? Is it an increase in cognition? Like, what practically could people expect to see perhaps if they tried this?
Well, cognition for sure is one of the first things we see with plasmalogen therapy. Their handwriting quality gets better. That's one thing that people see. Their handwriting gets better. Sleep. Remember, plasmalogens. So let me back up. So people have probably using this word plasmalogens, and probably no one has an idea what I'm talking about. They're part of your membrane structure, and so when your neurons, they're like a light switch on your wall, and one neuron has to connect to another neuron, and how it does that is biochemically. It sends molecules across this little chasm called synapse, and how it releases those neurotransmitters is a process called membrane fusion. And because all these neurotransmitters are kind of in a little ball called a vesicle, and that vesicle fuses and releases them, and then it goes across and connects to the next one, and that's how the light switch gets turned on and off. And you do this a lot, okay? An average neuron has about 50 to 100 times a second. You have those vesicles. The number of vesicles in the human brain are about the same number as grains of sand in the Hoover Dam. So you can imagine the entire Hoover Dam bursting and reforming 50 to 100 times a second. That's what's going on in the human brain. That's why it has such a massive human quantum computing power, which gives us our ability to basically, it's a quantum mechanical simulation. So anyways, plasmalogens, that this release of neurotransmitters, that membrane fusion process requires plasmalogens. And optimal neurotransmission release requires over 75% of the ethanolamines in the brain to be plasmalogens. As soon as they get below 75%, membrane fusion decreases. And what happens then is the overall signaling comes down. Not just the dopaminergic neuron in Parkinson's, but the cholinergic neuron in Alzheimer's, and even GABAergic for depression and anxiety. So we're dealing with, Alzheimer's and Parkinson's are kind of the canary in the coal mine. They're the weak links. Like, so if we give a plasmalogen reduction stress to a human brain, you're going to see predominantly cognitive decline. You're going to see vision issues. Then you're going to see Parkinson's related issues. Then you'll see, anxiety, depression related issues, because those are the ones, it'll all depend upon the robustness of those individual systems. But the stress is ubiquitous in the system. So that's kind of where, so for Parkinson's, you're going to see those, and then you have secondary issues, right? Sleep issues that come with those issues. And you want to, it's not just plasmalogens all by themselves. You want to make sure the mitochondrial health is in place. It's really important for Parkinson's patients to be on the proper B vitamins, because methyltransferase, they should be on phosphatidylcholine, like lecithin, creatine. Okay, you have to maintain. So all the neurofibrillary tangles, like when people talk about Alzheimer's plaques and tangles, all the neurofibrillary tangles of the brain are caused from methyltransferase defects. And your body needs creatine for your muscles and choline for your membranes. So plasmalogens by themselves, but you want to make sure you're on your B12, B6, folate, and then you have lecithin, good old-fashioned lecithin. You get it in a powder. You can get fancy stuff if you want, and then creatine, which is like cheap as dirt, comes in a big bucket, and you should be having that supplemented into your diet as well.
Wow, that's fascinating. I mean, I just feel personally like you have given so many people hope to at least alter their path.
And
Just with
this
this
is all in
knowledge.
your control. This is
Yeah.
not black magic. Your body, like, you can measure these things and you can put them in the right spot. Like, it's not like your biochemistry is personal. There's nothing more personal than your own biochemistry, and you have complete control over it.
Yeah, let's lead into Prodrome with that perfect segue, because a lot of the work that you do and the products that you sell are aimed at helping us know where we stand so that we know where we can then begin to improve. So I was browsing the Prodrome Neuro site a little while ago, and I know you have all sorts of lab tests. You work with doctors to do these blood
Yeah.
scans and brain scans and things like that. Tell us the work you're doing there and how we as individuals can sort of hop in on that and begin to take control of our health.
Yeah, so I basically teach doctors how to understand biochemistry. It's one of those situations that you spend your life in these large epidemiological trials, thousands and thousands of people in trials, and you sit up in your ivory tower and you look at people moving around, and you diagnose tests and you file patents, and nothing happens. So I basically said, it's someone else's job. But at some point in time, it says, you know what? No, it's not someone else's job. It's my job. And so this is rolling up my sleeves and actually teaching doctors how to understand biochemistry. The biggest thing for people to understand is biomarkers themselves are useless. Biomarkers are used to tell you something else behind the scene. So people try to move their biomarkers, like, what's your homocysteine level? What's your HDL level? What's your triglyceride levels? The value in those biomarkers are not themselves. It's what they tell you about the human body going behind the scene. You talk about cancer, for example, and people talk about intermittent fasting. A fasting cell cannot be cancerous, period, full stop. Okay, it is not possible for a cell in a fasting state to be cancerous. So the BRCA mutation in breast cancer, how that works is that mutated BRCA protein, BRCA protein, normally what it does is it elongates and extends, and it holds your fasting state longer in your cells. And when you have a mutated BRCA protein, your cells cannot maintain the fasting state long. So they're always skipping out of the fasting state. And so that puts the system susceptible to going into cancer, and that's how BRCA works. But you can neutralize BRCA by basically maintaining a diet program and supplement program that maintains the fasting state, period. And then it becomes neutralized. Same thing with the ApoE4 genotype for Alzheimer's disease. We can completely neutralize that genotype. I just published a paper on it a couple of years ago. Or no, last year, I guess it is. So anyways, the point of the matter is, so what Prodrome Sciences does is it tries to teach people, look, the human body is designed to work. Okay, it's not designed to fail, it's designed to work. And we know normality, health is singular. Disease is multiplicity. Okay, so you have a multitude of diseases, but you have a singularity, which is health. And we have decades and decades of data, normalization data. We know what healthy creatine levels are supposed to be, creatinine levels. We know what the HDL levels should be and all these things. So we know what health is. Okay, the definition of health is not up for question. We've been studying this for years and years and years and years. So the question becomes, if you're not in health, why? And how do you move yourself back into it? Inflammation is a big issue in our society. Like, we don't understand it. Mitochondrial insufficiency. So N-acetylcysteine and carnitine, again, really inexpensive, cheap supplement that you can get anywhere. Okay, can improve your mitochondrial function and increase your utilization. Get your triglycerides in normal. So what I teach at Prodrome Sciences, so Prodrome Scan, is kind of it's a simplified version of the massive non-targeted technology that I've been using for 20 years, where you measure thousands and thousands of molecules, which is, of course, uninterpretable to anyone else. And so we digest it down to core systems, your phospholipids, phosphatidylcholine deficiency. Like, even without diagnosing Steve Jobs, I can tell you in advance, if he had pancreatic cancer, he was phosphatidylcholine deficient. Okay, your cholesterol regulations. So people that are on vegetarian diets, sometimes they're not getting the right phospholipids. You can fix this stuff. But see, people feel that disease is so random and they're so powerless. Like, I'm just going to walk down the street and I have no control whether I get hit by lightning or not. And so, of course, we can't control everything in people's world, but we can at least look under the bed for the obvious boogeymen, and we can fix some of those. Okay, get those, because people don't measure phosphatidylcholine levels. Like, they just don't. And it's easy to, we organize it in such a way that's integrated. And the goal is to say, okay, here's a picture of your biochemical health. What is out of ordinary? Okay. And then where do we move into reserve capacity? Let's get your plasmalogens into protective space. Let's give you extra mitochondrial capacity. See, when people work out, everyone understands exercise, right? So I tell people, look, exercise is bad for you. Recovering from exercise is good for you. So what we do is we give our body controlled stress, and we wait. We recover from it. Then we stress again, and we wait, stress again, and we gradually step up our reserve capacity. So when you work out, the whole point of working out is to create a structural strength reserve capacity. So on the days that I'm not working out and I'm just moving my mouse around on my computer pad, I'm operating at a real low basal rate because I've created excess capacity. And that's the bottom line biochemistry, is you want to say, you know what? Technically, yeah, my body can make phosphatidylcholine, but it's energetically demanding to do it. So if I get the right number of grams in my diet, it's less that my liver has to make. Mm-hmm. And so what we want to do is we want to supply targeted biochemical intermediates to the human body in areas that are typically stressful to create reserve capacity. And then you can measure that. And if these markers are in the right space, your susceptibility to disease is dramatically lowered.
I need to get one of these, first of all, is what I'm thinking. And second of all, when you do this, you're working obviously through your doctor. Are you also, as your results are presented through your care provider, given a list of supplements you need to be on? Like, what do you get? You take the test, you get the results back. What are you telling us to do after that?
Basically, there's general supplements, kind of a starter program, if you will. There's some basic supplements that most of us just need to be on, and it's food. Okay.
Tell us what you think are non-negotiables. Let's include that, the non-negotiable list of supplements that people should be including in their diet.
People should be on lecithin. Okay. Good old fashioned. I use sunflower lecithin. I mix it with my olive oil and vinegar for my salad dressing. You can mix it anywhere you want it. Creatine, taking a few grams of creatine a day just improves. Creatine is made from your combination of your kidneys and your liver, and it's a big methyltransferase load because you want to. So creatine, N-acetylcysteine and carnitine. So N-acetylcysteine, inflammation is a big issue. People don't understand inflammation. Inflammation is what drives our diabetes. So when you're inflamed, where to start with this thing? So your body has protective mechanisms, and you have your immune system. So your immune system is designed to be an irritable, just, make me angry. Like they're looking for something to make them angry. Okay.
Like your angry next door neighbor that's like
exactly
75.
They're just nitpicking every little thing, right? And so what your immune system does is that, I'm trying to speak nicely here on TV but they're moving around, right? And they're sniffing, they're looking, come on, are you going to piss me off? Are you going to piss me off? And they're looking for cells that are not healthy, right? And because what their goal is to prevent sepsis. Okay, so you don't want, when a cell bursts open to die, there's a whole bunch of crap inside it, right? Mm-hmm. And you don't want that all over the place. So what your immune system is designed to do is it looks for cells that are close to death. They're getting close to being, and then they congregate on it, and they deliver the final death punch to that. And inflammation is supposed to stay focused on those systems that are unhealthy. What happens for MS, other autism, other diseases, chronic inflammation diseases, is that when your immune system, whether it's the microglia of the brain or your macrophages and your circulatory systems, that your surrounding cells, so when that macrophage comes to kill the bad cell, the one that's near death, and be there to clean up the garbage so the garbage doesn't go all over the place, then your surrounding cells are supposed to be healthy enough to sustain it. And those macrophages kill your cells by two things. One is glutamate, which is toxic, and the other one is it sucks up cysteine. It starves the cell of glutathione. So N-acetylcysteine and carnitine are designed they're designed to help protect the cells surrounding inflammation, so inflammation doesn't spread from its focal point. That's what you want. You want inflammation to stay localized and disappear. The problem is inflammation isn't a problem. What the problem is inflammation that spreads. You don't want it to turn like a forest fire that just burns until it finally burns out of all the trees. And that's what happens with chronic inflammation. So N-acetylcysteine and carnitine and your CoQ10, that type of stuff really is mitochondrial support. And that's really critical for, say, children with autism, because that's all mitochondrial issues. And then the second thing is neurological support. The plasmalogens, they provide the material, the building material to maintain membrane structure, especially the insulation tracts of your brain.
So that was lecithin, creatine, CoQ10, plasmalogens. We'll get this all, guys, put together in show notes as well. So I may send you a follow-up email to make sure that I'm getting the right things listed.
Yeah, and then you can tweak it here and there, little things here and there. But then lifestyle-wise, it's the biggest thing is intermittent fasting and moderate resistance training.
Okay, I have to hop in on that because I've heard multiple experts comment on intermittent fasting for women who are menstruating, right? So any age of the childbearing years, that it's actually not advisable to do that. I'm wondering if any of the research you've done has focused on that group of women. This expert who I believe it was Alyssa Vitti, I can't remember. But anyhow, she says that because men's bodies are on a circadian rhythm and we're on an infradian rhythm, right? We're on that 28 average day cycle where our bodies regenerate and renew on different patterns than men, that intermittent fasting might not be great for us, and that our needs change nutritionally according to weeks and sort of bigger groups of time than the 24-hour cycle with men. What are your thoughts on that? Well,
those are really good points, by the way. First thing is understand why you want to fast to begin with. Okay, what is the benefit of fasting? Now we can talk about how many hours you want to fast in, but fundamentally, your body has two gears. You have the fed gear and the fasting gear, and it likes to, and you want it to switch from one to the other very cleanly. In the fed gear, after a meal, that's like walking around town with your iPhone off the charger. It's consuming energy. Okay. And then when you're in the fasting gear, you're in the what's called the anabolic stage. You're actually building material. You build your hormones, you build your steroids, you build your membrane structure, and that usually happens overnight time. So we all, if you get an 8-hour sleep, you're supposed to be fasting at night. So back to the purpose of fasting. So when you're in the fed state, your intestines are generating energy from food being absorbed, and they're going into your liver and your cells, and you're using glucose. So you're in glycolysis, and you're not metabolizing fatty acids. Fatty acids that are coming into your cells are being converted into triglycerides and being shipped in your blood to be stored later in your adipose tissue, like your fat cells. Okay. And that's why after a meal, you can have high levels of triglycerides. You could have like triglycerides of 1,000, like super high levels. Like your blood could look white, for crying out loud. So that's in the fed state. Okay. You're not. So then at a certain point in time, you get through your glycolysis. Now that's all caloric. Like if you eat a lot of small meals, that means that you'll go from a fed to a fasting state relatively quickly, because you'll end up. But if you have a big meal, it can take a longer time to get into the fasting state. So that, and as we get older, that's one of the biggest problems getting older, is that the time it takes for us to switch from a fed to a fasting state gets longer and longer. When we're young, we consume our energy, we have a meal, and we're in the fasting state in a couple hours, for crying out loud. When we're older, it could take 4, 5, 6 hours. So the goal is to get into the fasting state. How you get there is up for your own personal life, and everybody should listen to their own bodies. Okay, don't like listen to an expert to a certain degree, but you ultimately, every single person is their own expert. So back to this whole thing. So when you get the fasting state, now all your fat cells are sending fatty acids for energy. Good old saturated fat. That's what the body runs on. Saturated fat, palm oil. That's what runs the human body mostly. And so then it goes in, and when it's in fatty acid metabolism, that's when your body makes things. That's when your hormones are made. That's when your membranes are made. You're anabolic. So that's why eating late at night is really a bad idea, because it messes up your evening your overnight fasting. So that's the bottom line. So you want to get into fasting state. How you do it is your own personal, what works the best for you personally.
Yeah. And, you know, I should have mentioned this at the top of the show. I feel like our listeners are probably savvy enough to know this, but we have to put this disclaimer on. This is not medical advice. This is for informational purposes. Please always, of course, ask your own doctors, just like Dr. Goodenowe said, for any personalized plans that you want to be on. Dr. Goodenowe, feel like I could pick your brain for days straight because you are a plethora and just like of knowledge and perspective on things that, it's just so incredible. But we do have to wrap here in a second. I want you to say before we wrap, there are going to be people who are asking how to get their hands on these tests that you're mentioning and how to continue to get support from your group after we take the test. So sort of speak to that group who is ready and willing to like go check out the Plasmalogins, the blood kit, all of that. And then we'll check in on where to find you on social media as well.
Perfect. Yeah. So at prodrome.com, you can find out all the information there. We have doctors all across the country in several countries around the world that we train. And so you'll be able to find a doctor in your network. There's obviously things that you can do yourself. Like everything I've designed, like I developed a lot of patents in the past and I basically burned them all. So everything is generally regarded as safe. So over-the-counter stuff. Plasmalogin precursors are all biochemical intermediates. N-acetylcysteines, the carnitines, all these things are complete human biochemical intermediates. So there's no prescription stuff, that kind of stuff. So it's completely available to anybody for any reason they want to use it for. So we focus on the blood work, lab work. We measure plasmalogens, we measure other molecules. We don't do diagnostics. That's for individuals and your doctors to figure out. And then we provide supplementation to restore biochemical health. And we have extensive training on drgoodenowe.com. It's basically an Alice in Wonderland. However deep down the rabbit hole you want to go, you can go deep and deep and deep into the science in autism, multiple sclerosis, cardiovascular disease, stroke, Parkinson's, like we mentioned, either ALS. So all these diseases in the biochemistry, these diseases are usually detailed quite extensively. So it's anything and everything is available to you guys.
Awesome.
Bottom line.
Yeah. And on Instagram, you are Prodrome Sciences, right?
I think so.
Yeah, I think you are. Check with your team. I'm pretty sure you are. But of course, as always, we'll link all that in show notes as well. Dr. Goodenowe, thank you so much for lending us your expertise for this period of time. I feel like we're all walking away so much more prepared to take care of our own health. So truly, thank you. Yeah,
you're very welcome. And people should not accept unhealth. Like you should expect to be healthy, expect health. And seek it. It's achievable, and we get seduced into thinking that it's okay not to be healthy. It's not. It's not okay to be healthy. That shouldn't be the default, right? The default should be seeking out ways to. I joked with you before, and let's pop producer Rachel. You can hop back on here too before we let Dr. Dr. Goodenowe go. But I joke. There's a joke in my house here. My husband says if there's a voluntary test to be taken, you do it. And he said, "What are you looking for when you take these cancer screenings and you run hormone panels and blood labs?" I said, "I'm not necessarily looking for anything. I just want to know what's coming down the pike a little bit." So I am going to be looking into I tell people it's almost like we're addicted to dying, right? We perpetuate behavior that we know is bad for us. Like, if you're a heroin addict, it's not good for you, but you can't stop taking it. And so we know it's almost like we're addicted to our own death, and that we continue to perpetuate behavior that we know is bad, but we just can't fix it. And so if we can create the right feedback mechanisms and try to remove some of this scary ambiguity, this actually isn't that complicated. Like, it really isn't. Like, if you can run an iPhone, if you can run your life, this stuff is not that complicated. It really isn't. Yeah, I wanted to read this too. I'm sure this is on your website, so you've heard it before. There was a testimonial from a medical doctor on there, and it says, Dayan Goodenowe has drilled down to the very core of what makes us tick. The implications of his inventions can't be overstated. This is the end of Alzheimer's, Parkinson's, cancer, and who knows what lies ahead in the paradigm shift to true wellness with the absence of disease. I feel like that sort of sums everything up pretty nicely, and I'm sure you're honored to get those sorts of accolades. It's funny, and just to plug someone else, I was watching Mike Quick a while ago, and it's like he was given the story of the 4-minute mile, right? And how people couldn't break the 4-minute mile because we had this mental blockage that it was not possible. It was not possible for a human being to run faster than 4 minutes in a mile until one person did it. And once one person did it, all of a sudden a whole bunch of people could run a mile under 4 minutes. And so we create these psychological barriers that are just false barriers. We put them in our way. They're just a psychological barrier. And once we get our head past that inevitability of death, the inevitability of disease, I have no power. It's not possible. Humans are only left to do this. As soon as you get past that mindset and say, you know what, even if that's true, let's have fun trying anyway. Right?
Sorry.
I have a question.
it.
What's the pushback you get from the current pharmaceutical state of the world, right? Where we're just treating the diseases in so many of the cases, and none of it is reverse engineering it, if you will, sort of what you do. What is it going to take to make that shift for the medical field to really be what you do, as opposed to what we're currently doing, which is just slapping Band-Aids on symptoms?
Yeah, that's a really good point. And I actually addressed that in the last chapter in that book, because it's easy to stand on the outside and complain to the FDA and complain to Big Pharma, but they've kind of been designed in that we've kind of created the monster ourselves. The FDA pharmaceutical industry, it's all based upon claim language. You have to make a claim for disease. You have to define a disease. It's all disease-based. It's not health-based. Right. Public health is supposed to be epidemiologically based, and we've lost our public health. You can argue about a bunch of things. The Bayh-Dole Act in the 80s was one of the worst things that's ever occurred, because it turned all of our academic public institutions into basically a farm league to the Big Pharma. So now they can just cherry pick IP. So all of our academic institutions and all our public institutions, rather than actually doing public research in terms of epidemiological stuff, like these cheap things I'm talking about, N-acetylcysteines, carnitines, you can't make money on these things because there's 10 suppliers. You can't run a $10 million clinical trial and then there's 20 different suppliers of the damn thing, right? So there's no way you can make a business out of that kind of stuff. And so I think it's not going to happen that way. I think what's going to happen is you're going to see this ground swelling of individuals, and the networks are growing more and more and more. And ultimately, Alzheimer's and dementia is going to be the straw that breaks the back. All systems they become bloated to themselves. And so long-term care, time to long-term care, people living longer and healthier, that's where the real cost in our society is. And what I think you're going to start seeing, especially with the aging demographic, is that's going to force some of this process, and it's probably going to come from the bottom up, and it's not going to come from those institutions. It's like saying, is Robinson May going to become Amazon? You can't. They're not structurally thought. You can't convert a Robinson's May into Amazon. Amazon became Amazon because Robinson May and Macy's and the big box stores couldn't be that, right? And so trying to retrofit some institutions just doesn't happen. And I think it's not about assigning blame, okay? Because our acute care medicine is really good, but doctors aren't trained to do that. We don't have the metrics to measure it. We don't have and so we actually have to do it ourselves. And I think you're going to start seeing that. And what I'm doing here with the network of doctors is take a scientific, big clinical trial perspective into population medicine, because that's my personal passion. My passion is population medicine. Okay, my personal goal is to change epidemiological incidence rates of diseases. Okay, not to fix a disease, but to actually say, you know what, the incidence rate of Alzheimer's disease is now decreasing in our society. Okay, how do we implement it? Like I said earlier in the pre-shows, that we actually know a lot about disease. We know how to fix a lot of things. We have a problem implementing our knowledge. It's not from a lack of knowledge. We have a lack of implementation of knowledge. And we have to kind of start creating these groundwork where we actually start educating people, get in the community, and that's where this will ultimately happen. And it's happening already. Like
That's what we're doing here.
that's exactly
Yeah.
right. People are doing it
Yeah.
all
And
the
I mean,
time.
anytime you can
Right.
empower somebody to ask more questions about their health or to take charge or to run another, I'm all for it. And, you know, frankly, the biggest changes in my personal life have been not from doctors telling me something, but from me listening to my body, seeking out
Yeah.
information, and then presenting that. So I'm all for the empowered patient. And I genuinely hope that's the future of medical
Well,
care.
people will feel like I'm 52. Like my eyesight, once I started putting myself on plasmalogens, my short-term vision completely restored. I can't wear my progressives anymore. Okay, so anything within 4 feet, I don't need glasses anymore at all. Period. Okay, I have no
Oh my
headaches
God.
at night anymore. My
I'm
workout
literally
routine,
going right now to buy this.
my muscle memory, right? I've always been a moderate
Right.
athlete, but now when I work out, I have no pain. These
Yeah.
little things, like your nighttime vision gets better. And I'm not obviously at a demographic for Alzheimer's at my age group. So people see these things. So people can
Right.
start, and they're doing that in their lives. They're actually getting functional improvements in their lives. I think that's all we can do. Is just in one person at a time. So anyways, I'm babbling.
You are the best.
We said we would gossip, and that's what we're doing.
Yes,
So,
I love it. I'm here for every second of it. And
So anyways, I'll let you-
I think you've provided so many people with a good foundation to begin their health journeys. So thank you, Dr. Goodenowe.
You're very, very welcome. Have
All
yourself
right, we'll
a
chat
wonderful week.
soon. You
Cheers.
too. Thank you. Oh gosh, guys, that was such a good episode. Like I said, I feel like I could have continued talking with him. I really wanted to get into specifics on Alzheimer's a little deeper. We covered Parkinson's. I wanted to cover autism with him, which is a controversial, his perspective, a controversial, but I feel a very necessary sort of perspective to take on looking at that. So anyway, we're going to have to bring him back. Long story short, we're going to have to bring Dr. Goodenowe back and make him a repeat guest on We Gotta Talk. Guys, if you haven't done so, this is me begging and pleading to leave a rating and review, specifically on Apple Podcasts. That gets this show out to people who will find it useful or interesting. So please do that. And thank you for listening. I'm so glad you've been here. If you're new, welcome. And please do come back. We have weeks worth of incredible shows booked with amazing guests here on We Gotta Talk. Live shows every Wednesday Eastern here on Facebook and YouTube. And of course, the podcast comes out every Thursday. WeGottaTalk.com/blog is where we write all of the stuff up as well. Check that out. Thank you so much for listening and watching. We'll see you next week.